All right, Tuesday test. Right, we moved it from Monday to Tuesday. So tomorrow we're going to review. Monday we're going to review. You guys on like seventh period, you guys get 2 days of review. All right, because they're going to the play today, so they miss out on that. Last topic today. It's our third day of dilations. We know, hopefully we're all pretty comfortable dilating a point. We go from the center to the point, use slope, and then double it, triple it, cut it in half, and we go from there. Today, dilating a line. Okay, how do I dilate a line? You guys already know, hopefully, I've done my job, and hey, this middle school mentality of things get bigger and smaller is out, right? Things get further away or closer to the center. And that's what a line does. Think about it. A line's just made up of a whole bunch of points. So all those points get further away or they get closer. Look at case number 1 here to the left. I got my center at O and a scale factor at 2. So from what I need from somebody first, what's happening to A and B? All right, what's happening? Not forget about the line. What is happening to points A and B right now if I have a scale factor of 2? What's happening to points A and B? Because they are not getting physically bigger, as you know. What's happening to points A and B up here? Let's start it off. Keating, what's happening?
They're getting further away.
They're getting further away. So very lightly right now, kind of like we did the construction yesterday, very, very lightly with your pen or pencil, whatever you're working with, draw a line from O to A that goes through it, very lightly. And on that line, eyeball it where you think A prime is going to be, right? Because it's going to double that distance. So you have a distance from O to A. Now that same distance from A to A prime. And then can you do the same thing for point B? Lightly draw in a line segment from O to B extended through. And then put where you think B prime is going to be on there. Double the distance. So just like we've talked about, the points get further away. Now go ahead, draw in that new line. A prime, B prime. See what happened when I dilated it by 2. Okay, there it is. So if I ask you what happened, everyone's going to say, oh, it moved. It moved. Yeah, I know it moved. Thank you. I know it moved. Didn't stay where it was. It moved. But what's the relation between these two lines? From a little vocabulary term way back in Unit 3. They are parallel to each other. Yes. So when lines are dilated, the original line and the new line are parallel to each other. All right. So when lines are dilated, they remain parallel. Okay, they remain parallel. Ooh, let's make a little note here too to help us out for later on today. What do you know about 2 lines that are parallel? I get it. They don't touch, they don't intersect. What about on the graph? If I had 2 parallel lines on the graph, what do you know about them? Same slopes, right? Slopes are equal. Good, Taylor. Okay, so when I dilate a line, the slopes are equal and they remain parallel. Everyone all right with this first case? Second case, notice where my center is now. On the line. That's a big difference for being off the line versus on the line. Here's why. Notice the distance from O to A. Keating says it's going to be doubled. Can you put where you think A prime is going to be? Put where you think A prime is going to land. Eyeball it. O to A has a certain distance. Where do you think A prime is going to be if I have to double that distance? I'm not too sure how far you put it away, but it should have landed where? It should have landed right on that line, right, everybody? Yeah, you have a point still on that line. Yeah, A prime. And guess what's going to happen to B when I double this distance from O to B? It may be a little bit more here, but probably going to be somewhere down there. So if I dilate a line where the center is already on the line, guess what happens? I don't like to say the word nothing, but it doesn't move. It's the same line. Okay, it's the same line. If the center is already on the line, it doesn't move. It's the same line. So A prime, B prime, that line would remain the same as the original AB. So see both cases right now. Center off the line, they remain parallel. Center's on the line, doesn't move. Same line. The center's already on there. And those are the two cases. I'm going to do two problems with you, and then I know this is going to be painful today. I'm sorry, you're going to have to actually talk to people in your group and do 3 problems together. And I know, what am I thinking? I know. All right, you ready? Here we go. Let's try these out, both cases. Line N, 3x plus 4y equals 20. We'll get back to that. I want a new line, though, called P, and that line's going to be dilated by a scale factor of 1/3 at 4,2. So quickly, before we start, are points going to get closer to 4,2 or further away based on that scale factor I gave you? Are points going to get closer or further away if the scale factor's 1/3? Halo? Closer, right? Closer. But hey, don't I need these points? I need to see this line so I can move it closer. So what I'm going to show you right now is, can we please graph 3x plus 4y equals 20 on the grid here so I can move them closer? 2 ways I'll show you to do it. Both ways involve your graphing calculator. We're not doing this old school, right? The calculator does it for us. So you guys know you can go to Grapher. Whoa, look at all those. Look at that. Listen to that sound of everything clicking there. Beautiful. You can go to Grapher. We can type it in, 3x plus 4y equals 20, just like that. 3x plus 4y equals 20. Everyone can type that in, all right? If you want to look at the graph, you can, all right? One way I'm going to suggest to graph this is you guys can go up to the table of values and graph all the points you can graph. You know, you probably want to stay away from the 3 and, the 4 1/4 there and 2 3/4, but any points that you can graph, go ahead and, you only need 2 points to graph a line. Only need 2 points. Okay, so if you want, why don't we just kick? I was going to have 2 ways, but I'll just keep it there. You can use your table. All right, if you'd like. The other way I was going to show you is if you graph it, I believe it'll show you points as you graph or as you move your dot up and down. Okay, so I guess you can do it that way, but that way's a little risky because you rarely get whole number points. So go to the table and just get that done. And again, you only need 2 points. Okay, you only need 2 points on the graph, so graph as much as you can. All right, so let's get a look at this line, please. Make sure, I didn't pass out straight edges, but I was going to say, please try to make. All right, so we got the line we're going to dilate. Going back to Halo's answer, hey, all these points are going to get closer, right? Closer to 4,2, because that's where we're dilating around. Anybody want to take a peek where 4,2 is? Anybody want to take a peek where 4,2 is? Where's 4,2? Oh, it's on the line. So guess where this line's moving? Nowhere, correct. Nowhere. So the line N had the equation 3x plus 4y equals 20. The equation of line P will also be 3x plus 4y equals 20. And it does say to explain, so how do I know it stays that exact line and not another equation? In your own words, I'm not looking for anything fancy here. Why does it stay the same line and not a new equation? 1-6, Maddie, talk to me. How do we know it's going to be the same line? What point? It's a specific point. What's the point? What's the point? Don't start. I'll put you in a headlock right here. What point did we dilate around? What was my center of dilation? Don't make this difficult on me. 4-2, which is the center, right? And where'd 4-2 land? On the line. Okay, the center is on the line. That's all I need. All right, the center is on the line. The center of dilation is on the line, is on line N, we should say, on line N. Everyone all right with that case when it lands? Next case, again, now it won't land on the line. And what the heck, how do I make this new equation if it doesn't land on the line? Okay, we have a new equation, 3/2 x minus 4, scale factor of 3/4. This is going to be centered at the origin. Whoa, origin, that's new. Talk to me real quick before I graph this line here. Rowan, come on, big dog, let's go. Come on, show your back in the game here. These points on the line going to get closer or further away from the origin? He's back. All right, he's going to get closer to the origin. Let's see those points, though, so I can get them closer to the origin. Go ahead and graph 3/2 x minus 4. Some of you Algebra 1 studs, I don't think you need to use the table. You can use the y-intercept and the slope if you want. Or you can use your table again. It's up to you. Just get this thing graphed. All right, let's go ahead and get it graphed. All right, now we need to move these points closer to the origin by 3/4. Ready? To write an equation of a line, we need two things. We need slope and we need y-intercept, as we know. Before you write the equation, because it's not, everyone agree, first of all, it's not going to stay the same line. Hey, here's the origin. That's not on the line, like the last problem. So it's going to be a new line. But based on what we did at the very beginning of class, what do we know about this new line and this original line? They're going to be what to each other? Parallel, which means they're going to have the same slope. There we go. Slope of this line up here is 3/2. Slope of my dilated line will also be 3/2. Everyone all right? How we got there? Dilated lines remain parallel as long as it's not the same line. All right, now here's where we got to work. What's my new y-intercept? Well, let me ask you guys, what was my old y-intercept on my original line? -4, which is the point 0, -4, right? Everybody agrees? Okay, where are we dilating around again? Origin, I think we got a shortcut, don't we? To find new points if I dilate around the origin. What's my scale factor again? 3/4. What do I do with the scale factor and the coordinates if I'm dilating around the origin to find the new points? We had that shortcut which said what? Multiply by the scale factor. So I'm going to take 0 and -4 and multiply them by 3/4 because it's around the origin. And I'm allowed to do that shortcut. So I take the old y-intercept, 0, -4, and I multiply by the scale factor. And that brings me to my new y-intercept. I'll let you guys do your quick multiplication there. And what's my new y-intercept here now? What's my new y-intercept? Sticks, Jonathan? 0, -3. Yep. So let's put the two together now. Slope of 3/2, y-intercept of -3. Looks like we're going with choice 4 here. Dilated lines remain parallel. All right, I promised you. I know you're so happy that you're going to have to work in your groups. Here's your challenge right now. You have 3 more problems in your notes to do. 3 more. Okay? You're going to do them. You can do them together. You can meet at the end and compare your results. But I want to be called over to your group when everybody has completed them and you all agree on the answers to the final 3 questions here. Once I give you the okay, you can go on to the homework assignment. All right, so however you want to do it all together, one by one, or meet at the end, it's up to you. But I want every group to call me over when all 4 or 3 of you have the same answer at the end. All right, so let's get to it. For you guys, when you get to number 5, you will need the distance formula. So there you go for number 5.
Scale factor to 0.06. It's the same line, but it's a different scale factor. So we can slope the equation so we can see if it's the same. 5 for the scale factor. That gives plus here when we start here 12 and not 0.6. Yeah, but then it would just be the same exact one. It is a bit. Because even if you're scaling that too, it's the same. It's the same line. I'm just doing what we did last time.